So before we begin today, let's take out the graphing trig functions 2, and let's go ahead and practice graphing y equals cosine x, y equals cotangent x, and then y equals cosecant x, okay? Those three graphs. And just pause the video, and I'll have the solutions to this once you're done, okay? All right, so you should have the graph of y equals cosine x now, okay? And one big feature is at x equals 0, it starts at 1, right? And then it comes down and then back up, and it repeats every 2 pi, okay? And then cotangent x, it has vertical asymptotes at every pi angle, so 0, pi, 2 pi, 3 pi, okay? And why is it above the x-axis right here between 0 and pi over 2? Because that's describing an angle that would put you into the first quadrant if you're going around that unit circle. And the ratio of x over y would be positive there because x and y are both positive in that first quadrant, okay? And then this one right here is negative because this describes this angle between pi over 2 and pi is in the second quadrant. And in the second quadrant, x is negative and y is positive, which would give you a ratio that's negative, and that's why the ratio here, the graph is below the x-axis, okay? All right, and then at pi, it's undefined, and also at 0, it's undefined. That's why you have the vertical asymptotes. Cosecant x, the next one, that's the reciprocal of sine, okay? So where sine is going to be 0, we're going to have vertical asymptotes, okay? Because the reciprocal of that, which is the ratio is 0 for sine, but when you do the reciprocal, it'll be undefined. So we're going to have a vertical asymptote at 0, at pi, at 2 pi, 3 pi, negative 2 pi, and so on, okay? All right, now why is the entire graph between 0 and pi above the x-axis, okay? And the reason is because this describes 0 to pi is the first and the second quadrant, and we know that the sine ratio is positive there, okay? Which would make the cosecant ratio also be positive. And that's why you have this, the entire graph between 0 and pi is above the x-axis. Between pi and 2 pi, the y coordinates are all negative, okay, which when you do the ratio of r over y for cosecant, okay, that would cause the ratio to be negative. That's why between pi and 2 pi, the entire graph is below the x-axis, okay? And at pi over 2, sine is 1, and the reciprocal of 1 is still 1. That's why this is 1. And sine at 3 pi over 2 is negative 1, and when you do the reciprocal, it's still negative 1. That's why this point right here. Okay? All right, we're just going to keep practicing for a couple more days, okay? All right. All right, now let's stop and we'll go to the lesson. So go ahead and take out your notes for this day. It's notes for modeling periodic functions from data, okay? Okay, so this is a table of data, okay? And it's the same information we get off the graph. We just have to look at it differently, okay? So from the graph, when we did these trig functions, we modeled using cosine, we were looking for maxes and mins, okay? So you got to go through the table on the y coordinates, and you got to look for maxes and mins, okay? So we're at 3, at x equals 0, we're at 3, and then we drop to negative 3.36, and then we drop to negative 6, and then we start coming back up. Okay, so this negative 6 right here, that's a minimum. Okay, and now at negative 3.36, we're coming back up to 3, then to 9.36, and then to 12, and then back to 9.36. That 12 is a maximum. Okay, and then 9.36, so from 12, we're starting to come back down, come down to 3, come down to negative 3.36, come down to negative 6, and then we're at negative 3.36 again. And what just happened is we came back up. So this is a min again. And then negative 3.36 to 3. Okay, we're coming back up. 9.36, we're coming up. 12, we're coming up. 9.36, okay, we're coming back down now, right? So 12, once again, that's a max. So our max is going to be 12 and our min is going to be negative 6. So you could also just go through the table and look for that. Okay, so 9.36, and then we're coming down to 3, down to negative 3.36, down to negative 6, negative 3.36. Now we just came back up, right? So this is a min again. And then negative 3.36, like I said, it's coming back up to 3, coming up, 9.36 coming up, 12 coming up, 9.36 coming down. Okay, so 12 is a max again, right? And then coming down 9.36, coming down to 3, coming down to negative 3.36, coming down to negative 6. Then we're good to negative 3.36 for the next one, and we just came back up, right? So this has to be a minimum. Okay? And so we're going to use the max and mins along with the x coordinates, okay, for some things, all right, to get the a value, the b value, the c value, and the d value, okay? All right, so to find the amplitude, okay, that is how much it's been stretched above the x-axis, okay? So what you have to do is you have to take the max minus the min, all right? And that would give you the distance between the max and the min, and the amplitude is going to be half that, okay? And that's our a value. So once again, a is our max minus the min and divide by 2. Okay, so for our max, that's 12 minus negative 6, which is our min. And we're going to divide that by 2. So 12 minus negative 6, that's really 12 plus 6, which is 18 over 2, and that's 9. Okay, so our amplitude is 9. Okay, that's the vertical stretch. It's going to be, the cosine x is going to be vertically stretched by a factor of 9. Okay, now let's go and let's find our period. Okay, and so our period, and that's going to help us to get our b value. Okay, so it's not, this is not going to be our b value when we find the period. Okay, the period is the horizontal distance it takes to repeat. Okay, so you could go from a min to a min, or you could go from a max to a max, because anytime you start at a min and you go to the next min, that's one full wave. Okay, now I'm going to do max to max. All right, but you could also do min to min and it would be perfectly fine. Okay, okay, so we're going to go this max minus this max. Okay, if you did min to min, you're going to get the same number. Okay, all right, so this max happened at 1.8326. Okay, this one happened at 0.7854. If I find the difference between these two, that will give me the period. Okay, so 1.8326 minus the 0.7854. I'm going to grab a calculator. I'm going to put that in. Okay, so let me clear it out. 1.8326 minus 0.7854 and 1.0472. So 1.0472. Okay, so that's how long it takes to repeat. It's going to take 1.0472 distance horizontally to repeat again, okay? That's our new period. And the normal period is 2 pi. The period has now become this. So I've done something to that 2 pi to get this, all right? So I have 1.0472 has to equal 1 over b times 2 pi. This is, okay, so our b value in our function, right? We always multiply by the reciprocal of that, okay, times 2 pi. What I'm going to do is multiply both sides by b, and that would give me 1.0472. B must equal 2 pi, or b is equal to 2 pi divided by 1.0472. Okay, so that's going to get us the b value for our function. That's going to be the, well, it's not going to be the, the 1 over b tells you that it's a horizontal stretch or a horizontal compression, okay? All right, so I'm going to take 2 pi from my calculator, 2 pi, and divide by 1.0472. And we get 5.999, okay? Because this is gonna, I made these so that they're nice values, okay? So if you round to 3 decimal places, that's gonna cause this to be approximately 6, okay? Because if you look at the fourth decimal place, it's 9. that will cause this 9 to be 0, that will cause this 9 to be 0, this will cause this 9 to be 0, and add 1 to the 5, which makes 6, okay? All right, so B is approximately 6. In fact, it actually is 6, all right? Now we got to find the C, okay? The C value is the translation to the right, okay? And what happened is for cosine, and this is why we use cosine to model, is cosine, the max usually starts at 0. But I look and this max is at 0.7854. That means it shifted to the right from 0 that amount, okay? So that's going to be our C, and that's our phase shift. That's what it's called when you do these periodic functions. So our phase shift is C, and it's equal to 0.7854, okay? And the last thing we need to do is our vertical shift, okay? And that's how much the translation, that's just translation up or down, okay? So vertical shift, and that's our D, okay? And this, okay, the X, this is like the new X axis that's moved on us, okay? Usually cosine is equally spaced, remember, above and below, right? So that X axis is right in the middle. The axis it's symmetric about, okay, is right in the middle of the max and the min. So if I find the middle of the max and the min, that tells me how much I've shifted it up, okay? So how do I find the middle? Well, you have to find the average of the two, okay? So this is going to be max plus the minimum and divide by 2. And what did we say our max was? It was 12, right? And plus our minimum, which is -6. And we have to average those, so we have to divide by 2. So this would be 6 over 2, which is 3. Okay? So we have everything for our function now. Okay? We have our vertical shift, okay? We have our B value, we have our phase shift, or I said vertical shift. Okay? We have our amplitude, right, which is vertical stretch, okay? We have our B value, which tells us the vertical or the horizontal stretch or shrink, okay? This has been shrunk by a factor of 1/6 horizontally, okay? Because it's always the reciprocal of this, okay? So the cosine function has been compressed horizontally by a factor of 1/6 because our B value is 6. It's been translated to the right 0.7854. That's called the phase shift. And it's also been shifted up 3 because that's our vertical shift. Let's write our function, okay? So I'm going to write f of x this time. Yesterday I was writing y. You can write y, it's okay. All right, but I'm just going to use f of x, okay, is equal to 9 times cosine, parenthesis, our b, which is 6, parenthesis, x minus the shift to the right, which is 0.7854, close the parenthesis, and then plus 3. And that is our function, okay? Now, I'm going to put this into our calculator, and I'm going to show you, okay, that you get these values, okay, or you're going to be really, really close, okay? So let me go to my graphing calculator. Okay, so from our graphing calculator, let's go ahead and press y equals, okay? And we have the function 9, and then cosine, and then 6, because that's our b, and then parenthesis, and then x minus 0.7854, close parenthesis, and then plus the 3, which is the vertical shift, right? Okay, so I'm going to go to my table, okay? And I'm going to enter some of the values off the table that I see, okay? So if I put in 0, I should get it out 3, right? That's the way to know if you're doing it right, okay? So it's close, right? Okay, let's put in where the first minimum, 0.2618, okay? So 0.2618, that's where the first minimum happened, okay? And what do we get out? -6. That's what our table says it is also, right? Let's go to the next max, right? 0.7854, 0.7854. And that's the first max. Yeah, we're getting the right values, right? And let's go to the next min, which is 1.309. and we got -6 again, right? And so you see how what we came up with, the function that we came up with, is producing the same data as this table, okay? And that's what it's called modeling, right? Okay. All right, so what I want you to do for the homework today, or the work, all right, is we already did this graphing trig functions too, okay? I want you to submit that, okay? Show me a picture that you did that, or PDF, okay, part of the PDF. And then I want you to do this worksheet GTF3, okay? So we did this on the 30th, okay? Or I did the lesson on the 30th, okay? You have a couple days to do it, all right? All right, you guys take care, and I'll see you on the next lesson. And that's it. Take care, guys. Bye.